Here we go with a question which is all about a standing wave which is formed in a string. Take a second to have a look, have a try, and then when you're ready to see an explanation of the answer, hit play. Okay, this one's a fairly simple one for IB. The key to doing well in this question is remembering what we mean by the first harmonic. So as sort of we've identified, the first step in this is to look at the boundary conditions. We're looking at a string, and so therefore we have fixed ends. And it even says here, this is fixed ends. This is a closed system. So what we're going to do is we're going to generate potential modes of oscillation, which are shown in the diagram you can see on the screen. Now we are looking at the first harmonic, that's the n equal to 1 harmonic, and so that is this one here. So we can ignore all the complicated ones, we're just looking at the simple oscillation that you would observe, for example, in a guitar string. Now, we've got 2 points P and Q, and we're being asked about their motion. Well, as you can see on the diagram, you can see that the antinode is going to form in the middle of the string, and so therefore P is going to be an antinode. The nodes are going to form at the extreme ends, and therefore Q is not going to be an antinode or a node, it's going to be somewhere in between. So therefore actually we can get rid of both of these answers because Q is neither a node or an antinode. P, it's reasonable to assume here, is an antinode. Now, if we look further at those answers, we can see that if P is an antinode, it has maximum amplitude of oscillation. If we move from P to Q, we're going to approach zero amplitude. So it is fair to say that Q's amplitude of oscillation is going to be less than P's, and therefore they do not generate, they do not have, the same amplitude. And you can see this on the arrows on the screen. Point number P is going to oscillate with a large amplitude, and point Q is going to oscillate with a low amplitude. As such, our answer C is out, and we're left with answer D, which is obviously the correct answer here. P and Q oscillate with the same frequency. You could think to yourself, what would happen if they didn't oscillate at the same frequency? The wave would become discontinuous, and you would have a broken system, and therefore the standing wave would not form. All points in our standing wave are going to oscillate with the same frequency. Hope that's clear. Thank you for watching, and if you've got any questions, please let me know.